This is a bit of a presentation on the voltage drops in your cables. I call it astrophotography, but people that almost use any type of camping or anything, it helps to kind of know about this stuff. And I've, both when I started and as I upgraded things, I've sometimes, even knowing all this stuff, fell into this trap and things weren't working quite as expected. So I thought, now's a good time to have a chat about it.
So what's an example when you say it wasn't as expected, as in?
My first problem was the mount was driving intermittently, and that's sort of pointed out there was low voltage. Put in a bigger cable and hey, presto, all fixed.
Yeah, any high current things, you'll notice it, like you might be doing something and your Jew controller might not be on that much or something, and it'll come on, it'll start drawing current, then something else will happen, like your cooler will kick in on a hotter night, or you can't pin it down to one particular thing, but it's not that hard to measure, and I've got some ideas on how you might do that. Now we come to voltage drop. The larger that resistance in a wire, the greater the voltage across that wire drop. So if you've got 13 volts at one end and you have 1 volt drop, you're only going to get 12 volts, or 12 volts at one end, 2 volts drop, 10. So the more resistance in the wire, the greater the voltage drop, and that's just Ohm's law. Also, the greater the resistance, the less current flows through it. You really want to deliver that current to your motors in your slewing, like in your mount. You want to deliver it to your Jew controllers. I'm picking the big power drive on your Astro setup, and your cooler, really. They're probably the biggest users of current, not counting if you drive your PC or anything on it. So the thinner the wire, the greater the heat generated, the greater the cable resistance, and the more voltage that's dropped. So in the reverse of that, to minimize that voltage drop, you try and shorten the wires, put your battery as close as, or your power source as close as to the mount as possible. Use thicker wires to reduce the voltage drop. So really you can do the overkill on the wires if you need to keep that battery. For example, we have battery mounted in the car. Like if you're going to have that distance, fair enough, but make sure you don't introduce voltage drop. Now, in case you were wondering about what type of voltage or power some of the gear uses, I've plucked some examples of some. So there's a couple of examples. Your Skywatcher mount is about 4 amps. You can see the EQ8, like the bigger one, is a little bit more. It's probably, this is going off manufacturer specs too. I haven't actually tried to measure any of these. So the astrophysics mount, there you are, 4.2 amps. It's very similar to the EQ8. There's a few amps between 2 and 5 amps on the those 3 ZWA cameras. I don't really believe that QHY600, but the specs say 3.4 amps. You can see 3 dew heaters there. Now I know your dew heater controller pulses that on, and you can set the settings, and depending on if you've got a dew point, one that just does it above ambient, or one where you just dial in the temperature, the maximum are those currents. So they're your next biggest heat or power users, and you can see that The biggest one there being the big band around the 9.25 edge HD at 2 amps. But they individually, they might not sound too much, but add them all up and it'll be it could cause a reasonable voltage drop from, say, your battery to your fuse panel. Then depending on the wires you use, that can cause a bit of a issue on your for those devices. How do we measure it? Now, for those that haven't dealt with electricity before, there's usually a multimeter. And multimeter, i.e. it's got a current meter, a voltage meter, which are called ammeters and voltmeters, and some other meters like ohms, and which is resistance, and a few other things. So it depends on the type of meter. I find I've got pictured there a clamp ammeter. So a multimeter has got current measurements, but the problem with that, you have to insert the meter in series with what you're trying to measure, whereas these clamp meters don't have that issue. They can clamp around the wire and measure the current. The only problem with it is you have to measure just one leg. So I'll show you how I get around that, but you have to kind of just measure one leg, not the positive and negative, just say the positive. And another way of measuring the total power being put out is to use a battery like I've suggested before, and there's an example of the state of charge monitor from my battery I have behind me, and you can get other ones as well, or physical ones. Now I'll just quickly show you that little multimeter. Like that's a bog standard meter, but you'll find, see the current, this has got two current probes and you have to set it in series. Now it's a bit hard to break the wires apart, insert that into the wiring, measure it, then take it all out. Like you're starting your camera up, stopping it, things like that. So it's not really practical for measuring current, but it's good for measuring voltage. And when it's all said and done, the voltage into the cable, the voltage out of the cable, that's what we're trying to measure. So that's the minimum, a voltmeter. This is also a voltmeter. It's got, I can plug the cable, I haven't got it in at the moment, I can plug those cables into the bottom of that and treat it just like the other multimeter. But this is a clamp meter for measuring current, and while you can get lots of types of clamp meters, you have to get one that can do DC. The cheaper ones only do AC. So this is a DC. Now the way you measure things is you can make up a little cable like this, just a little cable you can insert in your supply, and you can clip the power meter around that. There's a fairly heavy one for...
Greg, is that clamp meter sensitive enough to measure milliamps? You know,
it does, yeah.
Yeah?
It seems to.
Okay.
It displays less than 1 amp, and I don't really want to get into discussions on accuracy versus the display precision, but it seems to.
Okay.
And I'll show you, I'll give you some examples later. But like that's kind of okay for the source, and I've used it during my test to see that, you know, just measure current in source on a few different things. So it's kind of handy to sit there and see what your battery's using, for example. But something I find a bit more useful is I made one of these. Now these, you can get J-car. These are the barrel connectors. I just put, you know, female, male, and I keep the wires apart so I can clamp it around that. But I've also scraped the plastic off 2 bits and apart so I can't short them by closing them together, so it's a bit easier. So I can clamp the voltmeter around that. Now that's probably the most useful little gadget I made. Now while I'm on barrel connectors, and just so I can get two cables out the way, do you understand that there's a difference in these barrel connectors? They'll come saying 5.5 millimeters on the outside barrel, but there'll be the center conductor will be a 2.1 and a 2.5, and it won't be easy to tell. So one way to get a bad connection and not get the full current and voltage is to use, say, if your camera's got a 2.1 and you use a 2.5, it's not going to touch properly, because the 2.5 is a bigger hole, and it's not going to touch that 2.1, and you can't really tell. The way to do it, but there's a cigarette lighter cable, which I don't use anymore, and that's 2.1. Another cigarette lighter, that's 2.5. The most reliable way I tell is I've got the LED lamp behind me. I know that's 2.5. I think some computer supplies, the little connector on the back of those are 2.5s. So if I can plug it in, then I know it's a 2.5. If I can't push the 2.1 in, then I know that's really how the easiest way to tell. So have a known 2.5 socket off something, and try it. If it goes on, the ASI cameras, for example, are 2.1s, I think, and so don't use that, because that'll cause you grief. There's a straight away issue with a bad connection in the middle. So realize there's two types of barrel connectors. So there's your first, chance of trouble. Another way of measuring the current, I don't think they're that reliable, but I've kind of had this since camping times, is just to put that in series with your battery, and that'll kind of give you an idea of the total current and total voltage, or the initial voltage anyway. Okay. Back to the screen. I've just shown my experiment I'm just going to set up. Now I have up in that top left hand corner of the picture a dummy load I made. They're just wire wound resistors, 10 watts, and there's 10 of them, 27 ohms. That's about 2.7 ohms roughly. So roughly it's going to be about 5 amps. And that gets quite warm, but it gives me a similar power to look at what the cables are for some of those things, like the mount. I'm using a voltmeter to kind of measure the voltage, an ammeter to look at the load, and I may even fire up that Bluetooth app to look at my battery. So I'll just do that now.
So Greg, those that white series up the top there with they're different resistors that are going across the page, and you've just got them in series or parallel, I guess. Parallel, right.
Yeah.
And so as you move up, you'll just be able to measure different voltages.
No. I'll show you that in a minute. I only wanted to present a load. So it's all in parallel. So right, I don't know if you can see that, but I can't really hold it up higher. That's Bluetooth now to that battery, the Energize battery. Now all this is 27 ohm wire round resistors in parallel. That wire is just to sync some of the current better, but they're all in parallel. So if you do your formula on 27 in parallel 10 is 2.7 ohms. And it gets warm, but it's only to generate current. And I want current flowing through the cables because I just wanted to show you the difference in voltage drop across some of the cables. And I thought a practical way of doing it is better. So let's just put the alligator clip on the voltmeter. I hope I'm in camera.
Yeah, you are. Yeah, all good.
It's reading no volts, of course, but I don't know if you can see that. I didn't think of testing that beforehand. And I can actually either measure it over here or measure it here. Kind of doesn't matter. You've seen these power pole connectors, how they work, I hope. Basically, you'll always get positive, negative on them, no matter how you do it. And it's like a miniature 50 amp connector, and they're much more solid than a cigarette lighter, which if you pull the cigarette lighter apart, quite often it's only one of these little connectors and it just touches on there and there's a chance of them falling out, so they're not real robust and they're bulkier. There's no way you can fit 6 cigarette lighters in something, a small package like that. So I'll just make sure I've got no wires sitting on that because that does get warm. And we'll do our first cable. And I've measured these before, so hopefully it'll be the same. Now one of my favourite cables is cable number 1. Cable number 1, which I got off Amazon, by the way. And I try, if they don't have these little ferrite beads across them, I usually put them across, because I have a packet of them, and essentially just a ferrite core, the 2 halves, and you clamp it over it. And I only do it, you'll find a lot of cables will come with it. It's more there to kind of reduce some of that motor noise and spikes that sometimes get on your 12 volt power line. And decent batteries should filter that out, but it really depends on the length of the cable. The longer you've got cable and the more resistance, the less chance that battery's going to level out that noise. So that's why I sometimes do that. But let's get on with the measuring. Oh, before I do that, oh no, I'll do that once. Can you see that 4.8? That's what the battery monitor thinks it's drawing. And what does this think it's drawing? Oh, here, if I put it around the right way. This is saying, can you read that where my hand is?
Yeah.
4.71. So it's not far off, different. That should be identical. Yeah. So we'll put that there. Now, there should be hardly any voltage drop with this. So, what did I say before? All right. 0.26. Nice and toasty. So 12.91, that's what it's getting there to it now. And, oh, I should have made this a bit easier. .1, 13.16, and the battery is telling me 13.2, so I only do this once on the battery terminal, so it's basically not much difference. So I trust the multimeter a bit more, and the battery's kind of internal, so essentially that's 13.16 at the battery.
So Greg, your point is it's 13.17 raw, but after it goes through the cables, it's going down to 12.7, whatever the number
Exactly.
was.
That's why I just turned around to get 13.16, and I'll turn that so you can see it more. So we'll take that back, and this is going to be a comparison. So I'm starting off with the best cable, don't forget. So yeah, that's about the 0.2, which is what I've got in this slide that I measured at the time. That's using the first cable, using this nice thick cable and a 5 amp load. Now let's move on to our next cable and see some of the differences. So that's cable number 1 on the slide. Remember the slide?
I don't like the looks of that. Mine looks like the cable's at the left-hand ends.
Yeah, I'll just wait. that cable gets warm. So I was quite surprised myself. So let's go back to that. .6. What was
12.7.
Yeah, what I was going to do, what was the first one?
That's 12.9.
12.9, is it?
Yeah.
This is 12.65. So straight away, with a slightly, now this is almost the cable I recommend. Like that's not too bad, going from 13.1. But there is a slight voltage drop. It's not much between those two cables, like 0.3. So I wouldn't worry about that. Like for the motor, you might want to go for the thicker wire, but for everything else, this wire is not bad. It's what JCar call their 15 amp wire.
But Greg, doesn't that mean that your battery is losing, because the whole system is less efficient, therefore your battery is draining faster in order to keep the same power load?
Oh no, the battery is draining faster, but it's not changing its voltage. It's still for the 13.2 volt. There's so much.
Sure, but it's not going to last as long. So
yes, not going to last as long, but certainly at that 125 amp hour lithium iron phosphate, you know, at that power, you'll go for ages. Like you'll go all night. You'll go all night with 8 amps. Like,
Yeah, I guess to your point before is by the time you add up your heat shield and your motors and your laptop
Yeah.
and all the rest of it. Yeah.
oh, you'll drive the 8 amps and times 10 hours, that's 80 amp hours. But that's fine for that's a 125 amp hour battery. And because it's lithium iron phosphate, you can take it down to the, that 30%. If that was a lead acid, you couldn't drive that much current for 10 hours. And that's kind of the difference. You should stop at about 50%, 12.5 volts on a lead acid. When I say lead acid, I mean the types of mechanical constructions such as gel or the glass matrix, AGM. So it's the battery power capacity is a different story, but you can handle it. You can drive it.
So I
So
didn't quite get the difference between cable 1 and cable 2.
0.3 volts.
Dimensional length.
It's dimension. It's cross section. Can you see that in my? It's where my fingers are there. It's a thinner cable. Let me grab that other cable. It's a that's getting quite warm now. It's
Yeah.
like you can be tricked with thicker plastic, but you can see it's a thinner cable than this one. This one's got 16 AWG written on it, and this one's a JCAR 15 amps. So this is kind of, unless it's a really low current thing, this would be my minimum, like your normal wiring thing.
Yeah.
That one. Oh, toasty. So I've actually,
Right.
yeah.
Sorry, question. Is the thinner cable limiting the amount of current
Yes.
being supplied to the load? Or
Yes.
is it using up? Oh, it is. It's not that it is.
I know it's also
The
using,
thinner cable itself is using up because it's providing more resistance. It is actually presenting itself as additional load
it is,
to the battery.
it is. Or,
Okay.
no, it's not additional load, it's actually less load. The higher resistance you've got in the circuit, the less current flows through. The more, if you want the maximum current, put a short circuit. That will drive your current. You'll get get your 100 amps that way. But, and you'll blow things up too. So the lower the resistance, the more current. Now, the higher the resistance, the more voltage drop across it as well. So you can push more current through a higher resistance cable, but it will generate, drawing more current will generate more heat and you'll melt it. That's how fuses work. So it's a balance. It's not one or the other.
Power, right?
Eh?
It's lost power.
Yeah, it is. It's you're losing it in the cable, and it's not. And the whole circuit is getting less current, and the end device is getting a lower voltage, and that's why I've got the trying to measure the thing here at the end of the cable. So here we've got 4.6 amps. So I don't expect too much lower. It only 0.3 of a volt down. I think it was 4.7 before, so it's only a small amount of current less. So I don't expect too much with these two cables.
Greg, your point to some degree is from the video, and your point is, well, one of the points is like, because I've only got lead acid, right? So I didn't show out the AGM or these other technologies. So I can only go to 50%, and I can't drive as long. Therefore, I can make my battery last longer through using better cables, so my rig is more efficient. So it's drawing less on the battery to deliver the same voltage that the device is using.
It's think of the cables as getting more voltage to your device. It'll make stuff all difference really in the how long that battery lasts. Smidgen, but it's more about giving that device enough voltage, because they don't like you send them down. There's been some examples of power voltage getting down too low, and motors don't like them. Your mount won't like it.
So your point's more about you get very reliability out of your kit if you're delivering the right voltage.
If it's too low, it's zero reliability, which just won't work. If it's marginal, it'll work sometimes, it'll work other times. if it's higher, like I think your Skywatcher can take 16 volts. So, and it needs to do that because you drive your when you charge your battery, if it's across your battery when you're charging it, if it's say something like a lithium iron phosphate, or it'll be 14.6 volts on charging. So it needs to be able to handle those bigger voltages, 14 volts I think on lead acid, 13.8 as a trickle charge. It needs to handle those higher voltages. So you're better off with the higher voltages anyway.
The other thing, David, there is with an AGM, you lose voltage at the battery as you start to drain out of that battery. Whereas with the lithium, the voltage tends to stay up.
If you have it,
therefore, voltage loss on your cable is more critical with a lead acid battery.
yeah,
Keep the voltage up at the gig.
if you get halfway through the night and your battery's getting down, like say you're 12.5 on your lead acid, that's your limit. If you're at say 12.8 and you've got a volt left, you've only got 11 point something and you're getting too low. But if you're running at a higher voltage longer, because of it's got a flatter discharge curve for your lithium, then it's going to be less critical, that voltage drop in your cable.
Yeah, it's interesting because I remember reading some articles about the Kendrick heaters, because they've actually got a cut-off switch. When it goes below 12 volts, they just cut out. And so your dew heaters basically work down to 12, and after that they literally just turn off.
But you know what that's for? That's to protect your battery. If your battery gets too discharged, lead acid battery particularly, you'll wreck the battery. So
I understand, but that's the point. If you got a flatter curve, it's going to last for longer. Whereas if you got some which drops, it's probably more like that.
That Kendrick, you can turn that off too if you want. You don't have to have it on. But you're right. There's a few things with that low limit battery voltage drop in it. So you're dead right. Now we'll go to our next cable now. Now, just a reminder, we're on cable number 3. It's a slightly thinner cable, and this once upon a time was in the cigarette lighter version of it. I think my biggest cable. But
Greg, can you just show the battery connection clip? Because I just use cigarette lighter clips, and I know they're crap, but I'm just interested. So that's so you don't use the Anderson clips. I guess it's somewhere in the middle.
Okay. Yeah, I'll show you that. I'll give you a rundown on that. Both of these are Anderson connectors. You'll see this is called an Anderson SB50, and this is called Anderson Power Pole. These are typically up to about 30 amps, I think, and this particular one is about 50 amps, the connector. And you can get bigger versions of this to do, I think, 2 stages bigger, 150 or something amps. But this is typically, they call it an Anderson SB50. And a power pole. Now, if you look inside, I don't know how the lights are going, but it's essentially the same. It's 2 little bent springy clips, and the same. You can't plug a negative to negative. It has to go all the way. So always red, it always works that way. And you can make little cables like this, but so these essentially are the same type of thing. I've made all these, the other one I showed you I didn't make, but these ones I made.
With the 30 amp one, which is the power, which is not power pole.
Yeah.
Is there any difference in resistance between the 2 plugs? It's just heavy duty, so it's got a bigger gauge.
There's
you can handle more amperage, but effectively there's no difference in resistance or quality between the 2.
No, they're both very similar. I think there's the same type of resistance because it's the same type of contact pressure.
Yeah.
But every time you introduce a cable and a connection, you introduce a smidgen of resistance. It's the same as each time you put a fuse, like they're all got a certain amount of resistance, like they're pretty good. But every time you put some, so you've got to, not have too many. But don't forget, fuses have got to be big enough not to blow, but small enough for they go first before the cable does. Fuses only protect the cable, nothing else. They're not there to protect your devices, the cable in the devices, I guess, but it's more in case those cables short or something like that. They're there to protect the cables, the downstream cables. So it's always best to have these as close to the source as you can. Hence why I've got these fuses right on the battery terminal, because if these short here, like across the negative, these fuses blow right here. I can't short, unless you get a spanner between these two, the actual battery terminal themselves. So that's the advantage of the fuses protect, and they're always up as close to the battery as you can. Make sense?
Yeah. Thank you.
And you can actually make these things up yourself. Like that's a bought one, but I printed a plastic one of these and soldered the wires together and made one on one of my OTAs. So cable 3. When I tried this before, I got a 0.6 voltage drop across it. There it is. This is the type of thing you can just get in J-car actually, with a cigarette lighter on the end instead of this. So this is like it's a built cable. And these are the ones, unless you're just trying to do a little cigarette lighter, like a little, I don't know, USB thing or something like that, I wouldn't use them for kind of anything else. But anyway, we'll show you.
We can see that cable's cross section is a lot smaller.
Yes. So cross section is going to, that's a thinner wire, it's going to be more resistance, and hence more voltage drop. So we're dropped down to 4.5.
Reduction in current.
Yeah, 4.5 amps we're only getting through now, and 12.5 volts. So we've gone from 13.1 down to 12.5, so it's 0.6 odd volts drop. So that's an example. I don't think it's really getting, it might feel warm outside, but Doesn't feel that warm at the moment, maybe a little while, but that's a typical wire, and that's what I want to, if I do anything and get people away from these type of cables onto that J-Car 15 amp, that will be a bonus. Let's measure 12.53. Number 3. Now we've got number 4. Number 4. I always thought, figure 8 speaker type wire was always okay, and I've seen these connectors. I think this was on my USB hub originally. This mainly because I wrote USB hub on it, and it's a manufactured cable, but it's the same type of stuff as the, what's it got on it? C8A or something. It's the figure 8 essentially. But to drive this, how did I do that before? I quickly put some cables together before. I think I had it slightly different before, but it's okay. So that's almost dropped the volt now. So it's 12.1 volts, and we're only 4.3 amps. So we've gone from 4.7 down to 4.3. Not quite half an amp, but it's a reduction. Doesn't really feel as if it's getting warmer. But there's an example of that cable dropping down. That's my number 4.
You've got the wrong screen, Greg.
Ah,
That's better.
I'll do that again. I've got a little monitor behind me. It tells me that, just it's behind me. Slightly different voltage now, but it's 12.2 and 4.43.
You've lost nearly a volt.
Yeah.
And that's a killer.
Yeah, and like these, if that started to be like, I'll show you. There's a cable doubled. I don't know if that's completely in view. No, it's not. But it's not that big a cable. It's not hard to get a little bit longer, but by the time you wind to run a cable down from the top of your mount down the side, you give yourself a bit of a loop and go down to a battery or down to a fuse panel down the bottom somewhere. It's not hard to get more than that length in your cable. So now here we're getting into standard, like something you get at J-Car. I cut it at one stage and joined it again, but it's the type of things. This is cable number 5. So when I measured it before, it's almost 1.4 volt drop. But let's try it again. $11.7 or so. And we're only looking at 4.2, so we've gone from the thicker cable at 4.7 amps down to 4.2. So that's definitely half an amp difference that motor's not getting if you run a cable like that. Like, it looks alright, it's a cigarette lighter you're going by. This thing times out every so often and starts to give an alarm. So there's an example of even more voltage drop on a yet thinner cable. It's the type of, you know, red LED light that you get a thin cable. I really recommend you build your own cables, but that's another story. So I'll disconnect that just to get it nice and warm. And we're going to that last cable. Another cigarette lighter cable. Forget where I get this, but it's probably come with some gear at some stage. So we'll plug that one in. Now look at that, 9.9 volts, 3.5 amps, and that's timed out. AC, DC. 3.
Most of your gear's now not working.
Yeah, you're like 9.8 volts, even though we're still on 13.2, which we already know is 13.16 at these terminals. We're only 3.7 amps at the battery, but at the battery management system is slightly different, I think, their accuracy compared to something like a good multimeter. So 3.5 amps instead of 3.7, 4.7. So it's a whole amp less, and 9.8. Not so you definitely, and that's feeling warm now. So that's more dramatic if you try to run your system with thin cable, which I've seen before somewhere, and or if you just try to run your mount. So, and that's noticeably warm. You can feel that heating up. And it's only really using up 3.5 amps, not the 4.7, almost 5. So let me disconnect that so it's not burning the house down behind me. So they're up in on the screen, you should see now. There's some of the cables I used, and the gauges. There's my particular experiment with voltage drop. So that gets back to my suggestions. In high currents, such as the to the inverter. Now my inverter, the manual says I should have 100 amp fuse and that 6 gauge wire, and you can see I've done that. There's the thickness on my hand. Now I only do that so it just reminds me which one's which. If you look at Anderson SB50s, they're different colours, have got different plastic arrangements. So you get blues, greens, yellows, reds, but the black and the grey are identical. So a black will plug into a grey. Just to show you. Actually, it's a bad idea.
Yeah, that's a safer one.
Yeah, it's back in the same battery, but that will plug in. So I kind of just I have a black one just to remind me on my charger and inverter. I know I'll usually plug it into that one because that's got the bigger fuse here. It's got a 100 amp fuse, whereas this one's got this thinner cable has got the 40 amp fuse on it. So I showed you the 8 gauge. The 14 gauge is that thicker wire I've got here.
That's the one you recommend as the minimum. Is that the one? Is the minimum one?
Oh, that one, no, I wouldn't say that one was the minimum. I have it in a few instances to, for example, to go from a fuse panel up to the mount distribution, I think. And it's really the biggest one I could fit in one of these power poles. It's you start to run out of physical size. So I think this particular one I had to trim down to the plastic to kind of get it into the power pole. So I'd only use that maybe up to your fuse panel or something like that. The minimum ones are the 16 and 18s. You'll notice the smaller the number, the thicker the cable. So that cable 1, I think, from memory, let's go back, I'm pretty sure I wrote that down. That cable 1 is the 14 gauge. Yeah. So I kind of use it to drive my mounts, but it's the... And I've tried to get these thicker wires on these lugs. It's a pain in the neck. That's why you can see it's a manufactured one. That's why I bought it. It's not cheap, $30 or something. But that's why I've got these off Amazon, because it's hard to get that thickness of cable manufactured into that. So it's just easier, and they come with a plastic shroud which you can you get. By the way, these all click together. I should have had them broken apart, but these click together so you can kind of see little dents. You can arrange them any way you want. Just a standard power pole for these rig runners is that way, but you can kind of mount them all four. There's got 4 different sizes, and you can kind of slide the plastic on whichever way you want. But that's, I base mine on the rig runner, and it's the same as my astrophysics mount has those connectors on it as well. But they don't muck around with the baby connectors. So that's my favourite one for driving mounts or for driving motors. And as I said, I got it off 14. I don't know if you can see that, 14 AWG. So that's the thickest. You wouldn't want to go really only, probably the mount's the only one that you want to use it, or driving a small panel. The next one is really the 16 or the 18s gauge.
But David, the critical thing, particularly for you, is from your battery to your distributors, is that you're using something like 8 gauge.
Yeah.
Yeah, I'm using crap. I've just realised I got a whole weekend ahead of me rewiring my entire mount.
Like you can, the whole thing about voltage drop is it'll only drop across a resistance, and the way to give that resistance is to make it thin, to make a thicker cable, a slightly thicker cable but longer, So the idea is to go as thick as possible, as practical, and to go short. But if you need to go longer, try and go thicker. But you'll start to get limited by the cables, like the connector size and things like that. Now, I'll warn you, power pole isn't cheap. For example, I got this from I got those from Amazon. These type, that brand. But this one I got from, and you can hop on Bintel. From Bintel. They sell a rig runner, and they sell it in that size. I think they sell in the bigger size, but I find that size was a more practical size, a smaller one. But and you can buy these from actually overseas if it's a bit harder to get them over here from radio. It's like a amateur radio place that make these rig runners. The beauty of this one is, besides it's got 4, and you just put whatever fuse you want. And it's a 40 amp in, so it's 40 amp in, goes to a bus bar, then along this bus bar you put whatever fuse you want, and they drive these ones out. But it's got 2 USBs, which sometimes I find handy if you happen to be also driving something with your iPhone or your iPad and you're monitoring something, you can just kind of charge it with that. And that's but you can get it without the USB, and I think an extra fuse. But I think
I did look at them on Intel, but I remember my eyes watering.
Yeah, they were. I wouldn't surprise. Like, I can't really remember, but $260 or something wouldn't surprise me. Yeah. I think, but it did come from memory with one of these, with a length, and I think it had like a spade connector, and I replaced it with a SB50. But I think,
I like cabling and that sort of stuff and fixing around with those sorts of things. So I'm quite happy to get into it, and promote plugs on and stuff.
To
be honest, I've never really understood cable width. I knew the thicker the cable, the less resistance. So I guess I knew the concept, but I've never actually had recommended what's the size of the gauge. And basically, what I'm hearing is 14 gauge. Is basically what you should bring. Like that slide you put out before, which showed the different gauges for different usage, is actually quite useful.
Yeah, I find that the most. And look, I've got bits of paper, and you'll actually get some confusion between the millimeter width of the cable, the millimeter squared, the surface area, cross-sectional area, and you'll get differences in what they're equivalent to in gauges, and it gets a bit confusing. And it also gets a bit confusing because as far as current carrying capacity, there's open air, there's within a conductor, like another insulated, and underground and all. It just gets all too hard. And then you think, oh yeah, this gauge would be useful, but then you go and buy it, and that becomes difficult unless you want to order 100 meter rolls or something and pay multiple hundreds of dollars, because that's thicker cable's more expensive than the weight of it being carried. It's easy to go up to J-Car and get a couple of meters of this.
So the quality of the copper, like that's the one thing which I guess you don't really have a view on. Does that make much of a difference or not really?
It depends what you mean by the quality of the copper. And you got to remember that we're at night. It's not like we're running. If you were running this cable to carry the same currents and same distance to a solar panel on your roof, it'd be very different, because there's two things that come into play. Is the plastic. I think they use like a silicon base UV protected cable, and there's and it doesn't crack in that. And then you've got to look at the weather proofing of the cables. And another thing with those cables, when you look at the cable, you get braided, but it'll be silvered around or unsilvered, and that's more for marine use, like in a boat, and you're worried about if you're around moist environments. So if you, for what we need, my suggestion is use car quality cable. So it's the type of plastics where your petrol or solvent won't matter too much. It's probably not the best one to leave out in the UV, but something that you might pick up from JCar.
But we don't really do that because we're at night. So.
Yeah, that's I would not worry about all the fancy coppers or anything else. When it's all said and done, you can get wire that looks the same thickness, but they've cheated and had thicker plastic. You can get torque in particularly around what they call speaker cable, and because what happens, the higher the frequency, now we're only dealing with DC, so it doesn't matter, but the higher the frequency, the more the electrons go from the center of the conductor to the surface. So the higher the frequency, they go around the surface. That's why if you look on big coax cables and stuff, they'll often have the center conductor will be hollow, because it's the current's only traveling around the surface anyway. So with speaker cables, that's important, that big surface area. DC, don't worry. So bog standard, flexible cable from JCar in those sizes and with a decent connector. Now you can get one or two, JCar sell the power poles, and I've had practice of crimping them if you really need help. But I've got a fair few from JCar, but I've also got boxes, 20 or 30 or so from China as well. You can buy, again from the US and some of these kits, power pole crimpers. Like you can get the kit with the crimper, and say 20 connectors and things like that, all in a little kit.
Okay.
Now, I actually talked about fuses earlier, but that's just a rehash, because I think fusing is important